Next, we have Susan Nitta. Susan studies mechanical engineering at Stanford. She graduated from Gunn in 2011 and was active in Gunn's STEM community as a member of Gunn Robotics team and Gunn Girls Tech Club. Currently, she splits her time between working on the Stanford Solar Car project, mentoring the robotics team at Crystal Springs Upland School, playing violin, and occasionally being a student.
Hi, I'm Susan. As you said, I graduated from Gunn in 2011, so it wasn't too long ago that I was also sitting here in Spangenberg. So I realized recently that I'm now, okay. I don't know, okay. So I realized recently that I have 10 days left of school, so that means I'm taking a lot of trips down nostalgia lane. So we're gonna start with 2007 Susan, where I was just starting Gunn, and these were the 4 things that were important to me. And to put that in marketable skills, I suppose, playing violin for like 2 hours a day meant I had some amount of discipline, and being able to tell you the probability of if I could get 2 red socks out of a drawer of colorful socks meant that I could solve problems. Great, so I vaguely also knew that I wanted to be a surgeon, didn't really think about it. Any of these were equally likely, except for maybe being an astronaut since I'm too short. So notice that nowhere in here did I ever consider being an engineer, given that nobody in my family really knew what engineering was. So by lucky chance, I joined the Gunn Robotics team as a sophomore. I had a very unhealthy fear for hand drills. I remember the first time being handed a hand drill, I just kind of like jumped back and was like, oh, what's it doing? Somehow successfully managed to help construct this first robot. This was the 2010 robot, played soccer. And then the second robot was for my senior year, where it could basically play tic-tac-toe. So after 3 years on GRT, I guess my little red toolbox had these skills. But now I didn't really have a direction because I was rethinking the whole surgeon thing. What I did know after GRT was that I liked to make things. And because I was on GRT, that obviously meant robots. So after 1 year of college, I worked at Willow Garage on the robot development team. And what I did there was working on Project Duckburg. So these 3 robots were named Huey, Dewey, and Louie. And my project was to design and build a tablet mount so that Huey, Dewey, and Louie could roam around hallways and let you Skype in and interact with people like who are actually around the robot. So this was kind of the final version of what I had after my internship. One of the cool features of it was that it had a 3D printed part that had LEDs under it to tell you like, oh, the robot is going to move, so it would flash green. And for my presentation, they had it flash red, white, and blue. Great, so after that, I decided, okay, it would be really cool to make things that actually help people, because these robots were meant to help out seniors in senior homes to like fold laundry and do dishes and whatnot. So the following summer, I worked on a disaster relief robot in Germany at the Fraunhofer Institute. And this robot was supposed to kind of like scuttle around in disaster areas and take data on stuff like whether there were dangerous chemicals around or if there were like signs of life, so that people could then send rescue teams into the rubble. And I always felt that there was something missing about this project, and it wasn't until the following quarter at school when I worked on this fiberglass violin case that I realized what the problem was. And it was that I didn't have enough people around me, and I wasn't working in a team to solve problems. So in terms of where I was going, now my goal was to make things with a team to help people. And here's the running list of skills that I continued to acquire. The following year, I declared mechanical engineering because of the whole making things business, and worked on these projects. The top, I guess, right, is a duck that we actually tested during an open swim session at Stanford. I will never forget the lifeguard's face when all 120 engineers just like walked into the pool with these weird contraptions, and we're like, we're gonna test these right now for our final presentation. Otherwise, the second picture is of a device used to position the knee in an MRI. And the last picture on the side is of a rocket that we actually fired today. This project was one of the more engaging projects I had in school, and it was to help someone out who had an accident with a semi, and he wanted to continue pursuing his active lifestyle of running and lifting weights and whatnot, but given that he was missing 2 of his 4 quads in his legs, he didn't have the strength to extend his leg as much as he had to for either of those activities. So he pitched his problem to one of my classes, and my friend and I got to work on this. And you would think that the hardest part of this was to figure out, like, oh, how does the leg move, and like, how will we ever get the strength to assist him with that extending motion? But no, the hardest part was to figure out a system that he could use easily every day without like cutting himself on the metal or like dealing with 6 different screwdrivers. So that was an interesting project. So last summer I worked at Ekso Bionics, and I was the motion capture intern, which sounds pretty fancy, but my entire summer revolved around moving around cameras to see how the best places to put cameras so that they would pick up signals from the LEDs, then taping those LEDs to myself, and then prancing around and modeling myself as a skeleton. So Ekso is really interesting because they make clinical exos to help people learn how to walk again after they have some sort of paralyzing injury, such as a stroke. And I thought that was really cool, and when I got this project, I was a little surprised because I had applied as a mechanical engineering intern, but I wasn't exactly building things. And so at that point, I realized that sometimes in order to build things, you actually have to understand the system that you're building it for. So back to this thing, I wanted to start understanding systems to make things with a team to help people. So on that note, other projects I've been working on to try to figure out the bigger picture is the Stanford Solar Car project. And that is building an entire car from scratch and racing it across Australia. And I literally mean like bottom to top. It's about 2,000 miles, and it'll happen in October. And having to put together a system so complicated means having to understand everything that goes into it, from the basic mechanics of a car and how it's driven, all the way to what is the weather like in Australia? How fast are the winds going to be blowing? And will we actually have sunlight so we can charge our batteries? So that's one thing I spend a lot of time on. And the other thing I spend a lot of time on now is that I've helped start a robotics team at Crystal Springs Upland School. And what that's taught me more than anything is that understanding a system, so to speak, means not just the technical side of things, but also the finances and also what the climate is like at the place you're working at. So, for example, I would say Crystal Springs is not necessarily as engineering oriented as Gunn is. Like, they don't have something like a engineering night. So it's been somewhat difficult to encourage the school to support the robotics team. And of course, the people, there have been a lot of different types of people involved with working with the robotics team. And so this is kind of where I'm at now in terms of skills acquired over the last 8 years and also where I'm headed. And the coolest thing about working with the Crystal Springs robotics team is that it helps me connect back to the person I started out as before going through all of these projects. So, thank you.